I hate the cold. The last cold snap we had a couple of weeks ago in Land of Lakes decimated our trees. I'm particularly worried about the young and vulnerable Maya breadnut trees, Brosma malacastrum and the Moraceae, a valuable source of nutrition that sustained Maya civilization. I brought the seeds all the way back from fieldwork I was doing in the streets of Merida in the Yucatan in Mexico, and they were carefully planted and nurtured in pots in a greenhouse in Pennsylvania by Solar City's Vice President Janice Kelsey for 2 years, and then delivered to us at the Rosebud Continuum in Land of Lakes, Florida, to be planted out. They were doing great for a while. Then we got goats, and then the goats got the trees. The goats stripped off all the leaves, but they bounced back from near death, and they were budding out again. And then the cold front hit. 2 lousy nights with just a few hours of below freezing weather, and all the tropical trees were damaged. The leaves were shriveled and black on our breadnuts and bananas, papayas, chayas, katuk, mango, and moringa. This is despite the fact that we had watered and mulched and put blankets and burlap around the base of all our trees. We put an aquarium heater in 2 of our fish tanks, but many of our tilapia fish died, particularly those outside in our aquaponics area. Even our newly built DIY solar hot water collector, that's do-it-yourself solar hot water collector, which had overpressure relief, had one of its copper pipes split by the ice crystals where there was an irregularity in the copper. Now we know we must drain the solar collector, and we have to better protect our trees when it gets cold like that again. And the cold is coming again. Tonight. It's expected to drop to -2 Celsius overnight in Land of Lakes and stay cold for the next couple of days and nights. And that's enough to do damage. It also forces my wife and me to put our off-grid experimental fifth-wheel RV back on propane, that problematic fossil fuel that we've been replacing for many functions with our biogas and solar hot water, to get through the cold periods, which South Florida hasn't experienced for the past 8 to 10 years. We have to use a propane gas heater to stay warm. I bought 2 portable space heaters, one that is dedicated to propane, the other that I can modify to run on biogas, just as I've modified the refrigerator to run on biogas to complement our dedicated biogas stove. The problem is that the biodigesters that produce our safe, clean biomethane are essentially like the stomachs of cold-blooded reptiles. We even call them our domestic fire-breathing dragons. But like reptiles, they slow way down and hibernate when it gets cold, so cold weather means substantially less biofuel. It's a non-linear relationship. The digesters, like animal stomachs, do best at mammalian body temperature. That's 37 Celsius or 98.6 degrees Fahrenheit. A drop of just 10 degrees can cut production by half. A drop of 20 degrees by 3/4. A drop below 13 Celsius or 55 Fahrenheit puts the entire system to sleep. So in the winter, unless we put our digesters into a heated place or insulate them well and add heat, and unless we make or purchase a more expensive solar hot water system with heat exchange coils that have pumped antifreeze transfer fluid in them, we become reliant on fossil fuels again. And then we are complicit in causing the very climate change we seek to mitigate. I hate the cold. It makes everything more difficult, wreaks havoc with living systems. Freezing temperatures lock up water as ice, which essentially creates drought conditions for plants and animals. They literally die of thirst in the winter. And ice crystals burst cell walls, damage cell machinery, kill tissues and organs. Even without ice formation, cold slows down metabolism, puts different groups of organisms and microorganisms into hibernation, reduces the complexity of ecosystems. Perhaps this is one reason we tend to get stomach aches when we get cold, as the balance of microbes in our guts shifts away from optimality, and also why we can get sick and get a, quote, cold, as viruses and bacteria that are not healthy gain an edge as the ecocosm or microcosm inside us shifts. Cold reduces the ability also of many enzymes to do their job. It slows everything down. You know it from your own refrigerator. The refrigerator, a cold space, slows the growth of the living organisms that make our food spoil. And it also slows the growth of the living organisms that make our food and fuels and fiber and fermentation in the first place. See, cold is uncomfortable to living beings, because cold is the absence of energy. Heat is energy. Warming means molecular motion, chemical reactions, and hence metabolism speeding up. The rise of the mammals and birds after the age of the cold-blooded dinosaurs was the age of warm-blooded beings. It is believed that only homeothermic, or warm-blooded animals, are capable of the rapid biochemical processes necessary to evolve high intelligence. Cold makes us sluggish, makes us think sluggishly, it drains us of energy. I hate the cold. And the problem is that with global warming, we can expect more cold. How can that be? Certainly many undereducated or profiteering members of government don't understand how heat can create cold, and because of this seeming paradox, we had this embarrassing incident with Senator James Inhofe, Republican Oklahoma, when he famously threw a snowball in Congress in late February to ridicule the idea that 2014 had been the hottest on record at that time. It's gotten hotter since.
Of national attention, and in case we have forgotten, because we keep hearing that 2014 has been the warmest year on record, I asked the chair, you know what this is? It's a snowball, and that's just from outside here. So it's very, very cold out, very unseasonal. So here, Mr. President, catch this.
And at the beginning of 2018, we had President Trump ignorantly tweet, quote, "In the East, it could be the coldest New Year's Eve on record. Perhaps we could use a little bit of that good old global warming that our country, but not other countries, was going to pay trillions of dollars to protect against. Bundle up," end quote. And just the other day, on January 14th, he used the Suffolk Gazette's article about penguins that had hitched a ride on a container ship from the Falkland Islands in South America to Britain, showing up on a beach in England, to claim this was proof global warming was a myth. The irresponsible real estate mogul turned politician tweeted to his 47 million followers, quote, "Penguins have landed on a Suffolk, UK beach, so don't try to tell me there's global warming. Get real, people. It's cold out there. Penguins don't lie, only environmental fake news spreaders," end quote. And he put mental in caps. Well, get real yourself, Mr. President. We have penguins at the LA Zoo. Many penguins appreciate and even prefer warmer weather, even though they are adapted to survive extreme cold. And there are many species of penguins that live in warmer areas. The ones that were accidentally, not intentionally, brought to England that have appeared on a beach there were Magellanic penguins from South America. They're classified along the spectrum anyway as warm weather penguins, with the equatorial Galapagos penguin being the most adapted to warmer conditions. Although it is true they all still seek cool areas to release their body heat. Them being in England is no proof that they wanted to come there to get cold. Perhaps you might say they were following Paddington the bear's lead and were secretly interested in marmalade sandwiches. Well, you know what? They might hate extreme cold too. Whatever the penguins may feel, they didn't get to England on their own, seeking colder pastures. And seriously, the real point is that the oligarchy-favoring billionaire president and his oil and gas tycoon-saturated administration are using every angle they can to keep fossil fuels flowing and to keep the public confused. It's a classic example of what George Orwell called newspeak in his book 1984. It's part of a vast disinformation campaign that is plaguing the climate change issue. An article in Mother Jones explaining why such statements are dumb was called, quote, "Trump's cold snap tweet is even more shamelessly stupid than you had first thought. Here's why. Will he ever learn the difference between weather and climate?" But of course, most of these people actually do know the difference between weather and climate. They're just hoping you don't. They're playing to a horribly uneducated body politic and counting on the masses to confuse weather and climate, just as they spent decades trying to confuse the public with the medically absurd notion that eating fat makes you fat because, hey, the word fat as a nutritional ingredient sounds just like the word fat used to describe undesirable adipose tissues in an unhealthy body, which then allowed the sugar and starch barons to commit murder and sicken Americans by putting us on low-fat diets in which they replaced essential fatty acids and lipids in our diets with deadly sweeteners. Power politics, lawyers' arguments, and snake oil sales are all about word games, aren't they? A play on words by powerful men of letters can move armies. Hence famous quote, "The pen is mightier than the sword." And a lot of the public, the masses of honest people just trying to get by and unable to afford the luxury of studying postmodern linguistic deconstruction or hermeneutics, are fooled. As P.T. Barnum famously said, "There's a sucker born every minute." I was personally ridiculed at the checkout counter of a camera shop by two teenage saleswomen when I was buying camera gear and videotape to make a documentary on renewable energy farms in Northern California in the late 1990s. At first, they flirtatiously asked what kind of movie I was making, and I told them I was working with the Roseville Electric Utility on public service education films to help promote awareness of things we could do to mitigate global warming. It was unusually cold that spring, too, and one of the ladies said in a mocking tone, "Hey, Trudy, come here. This guy thinks global warming is real, and he thinks global warming can make things colder." The other lady came over and gave me a look like I was some kind of idiot and cackled, "Warming makes it colder? Duh! Can you believe this guy?" And they laughed and laughed as I left the store. I felt like quipping, "You might want to look in the mirror, your ignorance is showing," but I just smiled and waved. The sad joke is really on them, because even grade school kids get it. It's painfully easy to demonstrate how global warming could make things colder, as I used to do during those years when I was teaching undergraduate classes at Mercy College in New York, when we had the famous polar vortex, and it brought snow in the late spring. I would simply have one student hold an ice tray over the head of another, and have a third hold a blow dryer. I would say to the student under the ice tray, "You are New York in the late spring. The ice tray is the polar ice in the Arctic Circle above us. The blow dryer heat is the increased temperature of an ever-warming Earth. Now turn on the blow dryer and see how long you stay warm under the ice tray." Everybody got the point immediately, especially the kid who got cold water dumped on him in a visceral way. Now that's using your head. A few degrees of warmth on a planet that has water locked up as ice, miles thick in both poles and in glaciers in most of the mountains, can wreak havoc with the weather. The warmer it gets on average, the more freezing cold ice melt makes its way into ocean and air currents, disrupting patterns of weather in locally unpredictable ways. So we can expect more unexpected cold snaps and polar vortices. Here's a video with graphics to explain this, using the metaphor of a refrigerator door being left open.
Have you ever wondered how the rapid warm-up in the Arctic and climate change could disrupt winds at high altitudes across the United States, Europe, and Asia? Well, if you're like most people, you probably haven't given it a thought. But as a meteorologist, I'm paying close attention to what's going on because it often leads to weather like this. There's no place on Earth where the climate is changing as fast as it is here. You've probably seen pictures like this of Alaskan glaciers. This is 1902. Here's the same location now. In this part of Alaska, we're losing ice at a rate of nearly 2 cubic miles per decade. Not all glaciers are shrinking this fast, but most of them in the mid and higher mid-latitudes are melting pretty quickly. Here's another one. It's the Muir Glacier in 1941. Here it is now. These are maps of the Earth's surface temperature anomalies, or variance from normal, over the last few decades. Everywhere you see yellow, orange, and red is where the temperature is now averaging above normal. Look at where most of the global warmth is occurring. As a meteorologist, I am finding this pretty amazing because the warmth that I'm seeing in the Arctic isn't just at the Earth's surface, it's extending thousands of feet up in altitude. So why, though, should the warmth at high altitudes over the Arctic matter to us thousands of miles away farther south across the United States, Europe, and Asia? Well, it's all connected, and I'll show you how. First, we all know that the sun heats the equator more than at the poles, but what you may not know is because of that difference in heating, the atmosphere is deeper at the equator than it is at the poles, and this is important. That difference in atmospheric depth is what drives winds in the upper atmosphere, which travel around the world. Those are the winds that create our weather. They move storms, warm and cold air masses around. When the Arctic is anomalously warm, those winds have to shift south. In effect, the refrigerator door, so to speak, is opened, and the Arctic's warmth spills south, becoming a mid-latitude chill. Not theory. It's measurably happening. We saw some extreme examples of this in the winters of 2010 and 2011. The record cold and snow in Europe, the record cold in Florida, a rapid succession of snowstorms over the eastern part of the United States, and historic snows over the Great Lakes are all part of a pattern of record warmth in the Arctic, especially over Greenland and Alaska. This displaces the Arctic weather farther to the south. What's meteorologically interesting about this is that the effect is most prominent during the winter. That's when the temperature differences are at their greatest between the equator and the poles. So when the Arctic is anomalously warm, the mid-latitudes across North America, Europe, and Asia often end up like this. And looking into the future, global climate models continue to show change with a steady decrease in Arctic sea ice, a likely result of both warmer temperatures and disruptions in Arctic wind patterns. In the coming decades, climate models also show a significant increase in global temperature, especially in the Arctic. But this is an average. As the Arctic warms, there will be disruptions in atmospheric circulation. Some, as we've seen, won't be so warm. In this video, we've only touched on just one of the many potential impacts a warmer Arctic can have on us as it feeds back into the climate system. The notion that climate change is a good thing and that we're all going to be basking in warmer weather in the coming decades is most certainly a misunderstanding. As the world continues to warm so unevenly, it seems very likely there's going to be additional disruptions in storm tracks and precipitation across the northern hemisphere. Put simply, it probably means that most of us are going to end up with what used to be somebody else's weather.
Weather, you see, is the result of local micro-changes responding to climate, which is the long-term trend over larger geographical regions. The key concept in understanding global weirding through global warming is that it makes unpredictability predictable. That is to say, we can now say with ever greater certainty that we can no longer be certain about the weather. We can predict with ever greater accuracy that more locally unpredictable events will occur. The New York Times had a great article after Hurricane Harvey drowned so much of Texas called "The Real Unknown of Climate Change, Our Behavior." In it, author Justin Gillis wrote, "Every time some politician stands up and claims that climate science is rife with uncertainties, a more honest person would add that those uncertainties could just as easily go against us as in our favor. Quote, the truth is that the single biggest uncertainty in climate science is and has always been how much carbon pollution humans are going to choose to pump into the air. In fact, calculations have been run on this. If you want, say, a forecast for global temperature in the year 2100, the uncertainty about how much pollution we will spew out is at least twice as large as any uncertainty about the physical response of the climate to those emissions. So despite arguments like Pruitt's, a century of climate science has brought us to the point where we can say this definitively: we are running enormous risks. We are putting nothing less than the stability of human civilization on the line. And yet, most of us have still not bestirred ourselves to care, much less to march in the streets demanding change. We are like the people in Texas who did not take those flood warnings seriously enough, except that the stakes are so much larger. Is this failure to act the legacy our generation wants to leave for the generations yet to come? End quote from the New York Times. What we're worried about in large-scale changes leading to local disasters is disruption of the so-called ocean conveyor belt. That's the technical issue. The NOAA points out the global conveyor belt is a strong but easily disrupted process. Research suggests that the conveyor belt may be affected by climate change. If global warming results in increased rainfall in the North Atlantic and the melting of glaciers and sea ice, the influx of warm fresh water onto the sea's surface could block the formation of sea ice, disrupting the sinking of cold, salty water. This sequence of events could slow or even stop the conveyor belt, which could result in potentially drastic temperature changes, for example, in Europe." End quote. This is the reason that we in the sustainability field talk so much about following the precautionary principle. what we do here in America has potentially disastrous consequences elsewhere, and vice versa. The Paris COP agreement that Trump pulled America out of was supposed to bring us all together to acknowledge those synergistic effects and avoid the worst of them. And the precaution we have got to take now is to avoid the uncertain but certainly harmful effects of both having some regions of our Earth get too hot and others get too cold. Continued emissions of CO2 in some regions could trigger hurricanes or droughts or fires in others. And yes, global warming could also trigger an ice age in some areas. As noted in the 2016 article, Crippled Atlantic Currents Triggered Ice Age Climate Change by Eric Hand, quote, "The last ice age wasn't one long big chill. Dozens of times temperatures abruptly rose or fell, causing all manner of ecological change. Mysteriously, ice cores from Greenland and Antarctica show that these sudden shifts, which occurred every 1,500 years or so, were out of sync in the two hemispheres. When it got cold in the north, it grew warm in the south, and vice versa. Now scientists have implicated the culprit behind those seesaws, changes to a conveyor belt of ocean currents known as the Atlantic Meridional Overturning Circulation, or AMOC," end quote. Personally, I'm far more concerned about being caught in an area that goes through unexpected and sudden cold events than being in an area that experiences sudden heat waves. For my solar electric system or wind energy system, I have to rely on batteries, and batteries don't work well in the cold. When batteries freeze, they don't work at all. When it's hot, my batteries work better, and so do the microbes in my biodigesters, my domestic dragons. The biodigesters make much more methane and can handle much more food and toilet and other organic wastes that my dragons transform into methane and breathe useful fire from, a fire that offsets my use of fossil fuels. The hotter it gets, within reason, the more biogas and ethanol and fertilizers I can make, and with the biofuels and nutrients I have more energy and can make more electricity and grow more food, as long as I can keep the water from evaporating, as long as I can condense it when it does. With my absorption chiller or Einstein refrigerator, I can turn the heat of the biogas flame or ethanol flame into refrigeration. I can use the heat to run an air conditioner or a geothermal heat pump that can be also used for cooling. You see, with heat, we can make cold, but with cold, we cannot make heat. Warming is energy, cold is the absence of energy. There's only one positive side to cold temperatures that I can think of, and that is that photovoltaic solar panels do work better when the sunlight is super bright in a clear sky and the temperature of the panels is cold or cool. But I can also cool the panels down with cold groundwater and get hot bathing water and preheated cooking water in the process as a side effect. Yes, as global warming goes on, there are going to be places and times when it gets super cold. I'd like to mitigate climate change into not happening, but it is happening. And we can't stop it in any reasonable time frame, only lessen its effects and give the atmosphere a chance to recover for our children's children over generations. So we also have to adapt. Most of the things that I'm doing to adapt to climate change involve using the warmth it creates. But this week, we're going to see here in Florida, once again, how it also creates cold. And that bothers me deeply, because I hate the cold.